That's exactly what has just been observed among a swarm of unique pseudo-organisms called Xenobots, first developed in 2020 at the University of Vermont. Xenobots are effectively living robots, biological machines designed from the ground up using skin and cardiac stem cells derived from the African frog Xenopus laevis, hence Xenobots. The UVM team first spent months running an evolutionary algorithm on the Deep Green supercomputer cluster at the university's Vermont Advanced Computing Core to design and test the various shapes and functions these synthetic lifeforms might be able to use. Once their design was sufficiently refined, the team took a bunch of individual Xenopus stem cells and assembled them into the approximate shape specified by the algorithm using a set of minuscule forceps and electrodes. It takes around 3,000 cells to make a fully functional Xenobot, which can operate for up to 2 weeks at a time using their embryonic energy stores. Now, once these Franken cells were put together, they began to self-organize, using their cardiac cell contractions for locomotion to explore their environment. Researchers also observed emergent swarm behaviors, with groups of Xenobots working together to push and gather microscopic pellets into centralized piles within their aquatic environments. Researchers then realized that by cutting out a notch in each Xenobot and making it look like a microscopic Pac-Man, the bots could individually collect and shift even larger amounts of pellets using far less energy. This allowed the Xenobots to operate more efficiently and for longer time periods before running out of energy and, well, dying. Now here's where things get really wild. The researchers have found that by replacing the pellets with individual Xenopus stem cells, the Xenobots can gather enough cells to create a second generation of themselves. Essentially, they reproduced, creating babies that would self-assemble